Hey everyone, in today's lesson we will be covering notes number 2, and we will be talking about a lot of definitions and symbols today. Our first one is a line segment, and a line segment is a part of a line with two endpoints. What a line segment looks like is exactly that. Just draw a line segment. Don't put arrows on the ends in this case, but 2 points. And those are our endpoints. When you name it, you use those 2 endpoints in either order, and you draw a miniature line segment above it. It could be either one of those names. You don't have to use both. A ray is a part of a line with one endpoint. It goes on forever in one direction. And what a ray looks like is this. Start at a point, I'll call it point A. We're going to just go in one direction, arrow on one end, and this ray goes through point B. So we can call this ray A, B. The arrow that you draw over top of ray always goes to the right. This is the only way to name it. So you want to name the endpoint first. And the arrow goes to the right. Alright, a midpoint is a point which divides a segment into 2 congruent segments or 2 congruent parts. You see that word point as part of midpoint. And congruent just means that the 2 parts are equal in measure. So if you take a line segment, let's say that this is line segment AB again, and you split it exactly in half, that point would be the midpoint. So I'm just going to highlight that. So M is the midpoint, and that means that these 2 segments that are formed would have to be equal in length. So let's say they both have a length equal to 4 units. So we could say for sure that M is the midpoint of line segment AB. Alright, opposite rays are 2 rays that have a common endpoint and they form a straight line. So if we draw one ray to the right, and that starts at point X, let's say, and goes through point Y, and then we draw a ray going in the opposite direction, directly to the left, and it makes a straight line with that first ray. And let's say it goes through point W, then we can say for sure that ray XY, so we're starting at X going through Y, so I'm just going to highlight that ray. Right here is XY. That ray is an opposite ray to XW. Okay, so notice what I did there is, again, I started at X and I went to W. Whenever you name a ray, you always, always, always have to start with the endpoint. So X is our endpoint, that's our common point, and then you name another point on the ray. Another thing, the arrow always goes to the right. Remember that what we put up here. Arrow to the right, name the endpoint first. Okay, our next definition, parallel lines, something that you are probably familiar with. They're lines in the same plane that do not intersect. And to draw parallel lines, just do your best to show that they're never going to intersect. And then what you're going to see are little arrows on the lines to show that they're parallel. Okay, so those little funky arrows in the middle of the lines, and I'm going to highlight with a different color, those arrows indicate to us that the lines are parallel. So if I call the first line L and the second line J, we can say that line L and line J are parallel. Right, there's a symbol for parallel, which is a pair of, looks like absolute value. So we could write this as L parallel to J. That would be line L parallel to line J. Okay, our next definition is a set of perpendicular lines. Okay, perpendicular lines are two intersecting lines that form 90-degree angles. So I have one line here, one line this way, and typically we see a little box when lines are perpendicular. That indicates that we have a measure of 90 degrees. So I'm going to say line L and line J, and you are probably familiar with this symbol. You may not be, but hopefully you are. Line L perpendicular to line J. An angle is defined as two rays with a common endpoint. Alright, to get the visual on it, I can draw a ray starting at point X and going through Y. And if I draw another ray starting at X and going through Z, we have an angle. And we can call an angle YXZ. You can also put an arc there for your angle. That's just a preference. You can call this angle ZXY. Or, in this case, because there's no confusion as to which angle you're referring to, you could even get away with calling it angle X. One note is that the sides of an angle are rays. Okay, so the sides of that particular angle would be ray XC and ray XY. The vertex of an angle is the point where the two rays meet. Okay, so it's a point where two rays meet to form an angle. And so the only thing we have to say here is that X is the vertex. And it's just a point. So just put an X in there if you want to. Alright, continuing our discussion of angles, we have obtuse angle, acute angle, and right angle. And those names all have to do with the measures of the angles. Okay, the first definition, obtuse, an angle whose measure is greater than 90 and less than 180. So if I draw an angle and say it measures 120 degrees, we can say angle B, let's call it angle ABC. We'll say the measure, so M of angle ABC equals 120, and that makes it obtuse because it's greater than 90 and less than 180. An acute angle has a measure that's between 0 and 90 degrees. So acute, I want to draw a smaller angle, and I'm going to say that it's 45 degrees. Let's call this angle IDK. So we can say the measure of angle IDK equals 45. So that means that angle IDK is acute. Finally, we have a right angle, and that's an angle whose measure is exactly 90. So this is angle BAC. Notice that little box in the corner, that's our right angle symbol. Again, that means it measures 90 degrees. There's no confusion for this angle, so we, actually on all three of these, we could have used a single letter. So I can say the measured angle A is equal to 90. All right, the last thing that we need to talk about today is the word congruent. Congruent, sometimes people just assume that it means things are equal. It's a little bit more than that, but most often we do use it to say that two things are equal. So congruent objects in geometry are two things. Could be two line segments, two angles, two things that are the same size, same exact size, and the same shape. Alright, so where congruence comes into play, we're going to talk about congruent line segments. So if I have line segment AB and I know it measures 2 centimeters, and I have another line segment CD and it also measures 2 centimeters, we can say that line segment AB is congruent to line segment CD. That symbol right there is the congruent symbol. So that means congruent to, equal in measure to. Alright, in geometry we often have to answer a type of question that I refer to as always, sometimes, never. Alright, so we're going to use A for always, S for sometimes, N for never. So we're trying to determine if these statements are always true, sometimes true, or never true. We can draw a diagram to support our answer, or we can put it into words and explanation. The first statement says two lines intersect at only one point. So if I have two lines and they do intersect at one point. So this is always true. So I'm going to write the word out, I guess, instead of just writing the letter. Okay. We learned on our first day in class the intersection of two lines is a point. That's a theorem. Right, the next one says a plane contains 3 points. Always. We have to have 3 non-collinear points in order to determine a plane. Okay, so 3 non-collinear points. Remember that's how we can name a plane, is using those 3 non-collinear points. The next one says a line and a plane intersect at exactly 2 points. Never for this one. Either your line is going to be completely in the plane, so all points, or your line is going to come down through the plane. So remember, it goes dotted when it goes through the plane. Okay, so either it intersects in all points or 1 point. Alright, the next one, 2 parallel lines do not share any points. That's always true. That's the definition of parallel. They don't intersect. Alright. The next one says an angle measuring less than 180 is acute. Oh, tricky one. It's sometimes. Because if it measures less than 180, sure, it could be acute. It could be 30 degrees. So that's a yes for this one. But if it measures less than 180, it could be 120 degrees. And 120 is not acute, so this would be a no. So because we found a counterexample, that's what this is, a counterexample. In other words, it's a case where the statement is false, and that takes the statement from always and knocks it down to sometimes. All right, 3 lines intersect at one point. This one is also going to be sometimes. What you want to do for these questions is think about, well, could it be true? Could it happen that the 3 lines intersect at a point? And the answer is yes. Okay. But do 3 lines have to intersect at a single point? And that answer is no. I can draw something like this. So again, because I found one counterexample, I can't say always. The next one says 2 right angles are congruent. So if this is a right angle, its measure is 90 degrees. If this is a right angle, its measure is 90 degrees. This is always true. Right angles are always congruent. All right, our last one of this type says a midpoint divides a segment into 2 unequal parts. Well, that's just false, so we'll say never. The definition of a midpoint is that it divides a segment into 2 congruent parts. So if we have a segment and this is a midpoint, this segment would be congruent to this segment. All right, those little lines that I just drew on those pieces, those are tick marks, and they're used to mark things congruent to each other. Okay, this last section is kind of fun. We're going to take each of these items that are on the left-hand side, are plane, segment, ray, point, and line, and we're going to choose one item from each of these 3 columns. Okay, so I'm going to work with the first column and see if I can figure out where each of these things will go. So I'm going to put these letters in blue in the first box here. All right, so for A, it says it extends forever along a given direction but has no width. All right, so extending forever, it could be a plane, it could be a line. It's saying that it has no width to it, so that's going to be a line. A flat surface with no thickness is a way to describe a plane. Part of a line to one side of an endpoint sounds like a ray to me because it's saying going to one side. Has a location but no size or shape. That's a point, like point A. So that's going to go in here. And then finally, part of a line, also the shortest path between 2 points. All right, that's a segment, so that would be E. All right, into the next column, we've got notation. All right, this first one, F, there are no arrows on the end of that segment, so it is a line segment. This one has arrows, so this one is a line. For H, there's a single letter, that's a point. This one has the word plane. If you miss this one, we need to talk. That's a plane, I. And the last one, this guy has an arrow going to the right, only in one direction. That's a ray, so that's going to be letter J for that one. The last column, what it looks like when you draw the picture. K is a line segment because there are no arrows on the ends, it stops at each of those 2 endpoints. So segment gets the K. Now we've got arrows on the end, right here and right here, so L is a line. M is a plane, it's drawn there for you, so that'll be M. Okay, so used up all those. N, that's pretty easy, that's a point, just point A. And finally, notice that that arrow is going off to one direction. That's a ray. So there it is. All right. So next steps would be to complete the practice, all right, the learning check, and then the reflection. All right. As always, let me know if you have any questions or need any help.